When I was asked to do this, I wondered why was I picked, because there were 6 project managers for Nimbus. I was the last one. Then I checked out and found out there was only 2 of us living. And Harry Press was out in Oregon, so that left me. But what I'm going to do today is cover 3 areas. One is the Nimbus background, the history of the start. Second would be some first, but I think Chuck has done a better job of covering first, so I'll go through that rather quickly. And third will be my observations during the period of time that I was a process manager for a Nimbus and Landsat. Well, the Nimbus story begins with the first U.S. meteorology satellite at the Army Signal Corps up at Fort Monmouth, when Bill Stroud proposed an instrument, a cloud cover measuring instrument for Vanguard. It was one of the 5 or 6 instruments that were chosen for Vanguard that would have flown over the various missions. It did fly in February of '59 and operated for 20 days on a battery. It was not a solar cell satellite. That was a forerunner of Tyros, that program. And that was a part of the IGY, International Geophysical Year, that started in '57. So it was selected in '57, flew in '59, and then the first Tyros flew, of course, in April of '60. Well, that crew, the Bill Stroud and company, transferred to Goddard. When Goddard was being formed, various groups came together, were brought in mass. First one being the group in NRL, which was the Vanguard group. I came in after that. And one of the next ones was the group out of Fort Monmouth. It's about 14 or 15 engineers and scientists. And they came to Goddard in April of '59. Well, I hope I don't have to back up. I hope you can hear me now. Okay, sorry. That team that came down from Monmouth consisted of Stroud, John Lick, Rudy Honnell, Rudy Stomfel, Bill Nordberg, and Bill Bandine. They actually did the design and architecture for Nimbus. So they were key in getting this started. And I'm sure there are others, but I got this history from some of Ralph's stuff and some talking to a few individuals. So if I left anybody out, it was no intention to do that. Soon after that, they came Stroud and Ed Courtwright, who was then at headquarters, did a tour of the United States, finding out what the interest was in follow-on satellite, a research satellite. And they then came back and developed the specs and the objectives for it. So that was later in '59. By '60, fiscal year '60, which would have been mid-year '59, Nimbus was established as an R&D program to serve as a Tyros replacement. There were going to be 3 satellites, one of them paid for by NASA, and 2 by what was then ESA, the Environmental Satellite Services Administration. I knew Ralph would get me straight. And that got it started. That was a kick. Oh, I'm sorry. I was worried about going backwards. I didn't go forward. Okay. All right, well, we're with it now. Well, problems developed, as it always happens on satellite programs. None of us have been on one that didn't, certainly in the beginning. And these problems caused ESA to drop out. In '63. So Nimbus at that point then became an R&D platform for satellites, Earth remote sensing. It was originally conceived as an in-house project, and some of you were around here in those days. There was a lot of in-house activity going on. There were, in most times, 3 or 4 explorers being worked on and 1 or 2 observatories, either parts or all being worked on. So it wouldn't be unusual to bring to make Nimbus as an in-house program. But it wasn't. Of course, it was contracted out with General Electric. It was that design that was developed by the Stroud team was really a 5-foot diameter ring, which would hold the electronics, and the base then would hold the instruments. And as you've seen in the models around here, the instruments pointed down from there. And it was mentioned earlier also, the sun synchronous orbit was selected to provide observation continuity and repeatability, about 1,000-kilometer circular orbit. Launches were from Vandenberg to ensure we would get the sun synchronous orbit, and the midnight launched at midnight to get to noon equator ascending node orbit. The first 4 Nimbuses were on the Thor Agena. The last 3, 5, 6, and 7 were on augmented Thor Delta, or Delta, we call it in those days. As you've heard already, each mission was progressively higher resolution, more complex, as Nimbus 1 had 3 instruments, Nimbus 7 had 9. Nimbus 7 was designated as an environmental monitoring satellite. And I remember when I was brought on board, that was something that was pointed out to me. It was a difference from the previous missions. They hadn't used that terminology. But it really was a predecessor to the Earth observation satellites and the ISAT that's ongoing today. As you've already heard, there's been, over the 30-year period, 33 instruments have been on board the 7 Nimbus satellites. The operating lifetimes are kind of interesting. The first mission, and I find this surprising, but that's what Ralph's history tells me, had a 6-month lifetime. It did not meet it, of course. It had the problem with the solar array drive locked up. But 4, 5, 6, and 7 had 5-year lifetimes, and they all went beyond that, all the way out as far as the Nimbus 7, 15 years. So a lot of good data was gathered out of those 7 missions over that 30-year period, which would have only provided you, if it just met the mission lifetime, far less good usefulness. The Nimbus first, and Chuck has touched on some of these, the Nimbus 4 was the first one with an onboard computer using TI integrated circuits. And it was the first civilian satellite with 3-axis stabilization to 1-degree accuracy. There probably were satellites that they don't talk about in open forum that had a greater pointing capacity, but this was the first in a civil satellite. And the first RTG that was on Nimbus 2, and then, of course, was lost and then recovered, as was mentioned earlier. Thank you. Okay. Continuous operations, and the continuous means ongoing, began with, at least on these 3 instruments, the IRIS, the BUV, and the TOMS. The IRIS started in April of 69, the BUV on April of 70, and in October of 78, the first TOMS, the ozone mapping instrument. The twirly rams, which you'll hear more about later on, was first to do for the forerunner of international search and rescue. They never called it that, but actually the Nimbus basic spacecraft was what I would call the first multi-purpose spacecraft. There were 10 of them. 3 of them for Landsats and 7 for Nimbus. And in those days, I don't know of any other program that had that length of missions using the same spacecraft, same basic spacecraft design. The Nimbus 7 measured sea surface temperatures. I'm not sure where Chuck mentioned that one. I'm sure it's on his chart. And one I'll talk to a little bit later is that we did the first field disassembly on Nimbus G, or Nimbus 7 later. Now with some of my observations as project manager. It was obvious when I was asked to join the project, and I had never worked on an Earth-pointing mission. I had been involved with missions that were science missions looking at either astronomy, high-energy astrophysics, or fields and particles in situ measurements. The team I determined very quickly was a very competent, very good team. And I learned something from a fellow named Edwards Deming, who was an expert in, efficiency expert. He's the guy that went to Japan and straightened out their auto industry right after World War II. He said, the willing worker will always do the right thing if management doesn't screw them up. And I was determined not to screw them up. And this gang of folks, some of them of which are here, were outstanding. It was no problem they couldn't tackle, and they had worked it from the basic design to getting data products out in a timely manner. Something else I found out joining that project is you had at that point 4 satellites on orbit plus 2. That would be 3 Nimbuses, 1 Landsat, and 1 Landsat and 1 Nimbus in the assembly stage in preparation for launch. So it was like a whole new ball game. Not only did you have to be concerned with getting the ones up at Valley Forge built and launched, but you had to worry, is Ralph going to call me in the middle of the night and say that the tape recorder stopped or something? But he knew it wouldn't do any good to do that, so he didn't do it. Another thing we found that this mission, Nimbus 7, didn't have principal investigators like earlier missions had, and certainly not like the science missions I'd been used to. Instead, they were the experiment teams, and they defined the instrument requirements, they defined how it should be built and tested, and they also defined the algorithms for taking the radiances and converting it into useful information. So they went cradle to grave, and those were very, very good, competent teams, anywhere from 3 to 7 people per team. Also found that you can never please all the scientists, certainly with giving them enough calibration. I had an occasion on Nimbus 7 when it's going into thermal vacuum, final thermal vacuum test as an integrated observatory. Got a call from our guys who are up there working it. They say, we cannot satisfy one scientist. He will not say we're ready to start thermal vacuum because he has not had enough calibration. So I grabbed a car and a bottle of scotch and I went up there to talk to him. It was an interesting conversation, and I thought I was going to have rebellion, but after about half the scotch was gone, they were convinced that we'll make it work because I said, we will go into thermal vacuum, and we'll tell the scientists that's just the way it is. You'll fly, you don't fly. And I said, by the way, if he really gives you a rough time, you could put him in a chamber with it, but it's probably not a good idea. Well, it turns out that instrument operated for 15 years. So I guess he had enough calibration because he put out a lot of good information. Another interesting one that I guess it better. Yeah, here we go. I got a call one day from the center director, Bob Cooper. We already had shipped Nimbus G out to the Western Test Range and preparing it for mating to the Delta. And he said, solder balls have been found in a tape recorder at RCA, and those tape recorders are just like the ones on board your spacecraft. So disassemble them, take them out, and have them inspected. So I go to GE and say, I've been directed that we need to take out those 3 tape recorders and inspect them. And their reaction was, you gotta be kidding. We don't do field disassembly. We never have done field disassembly, and therefore it will have to be taken back to Valley Forge and disassembled up there and then subjected to a whole new series of tests. And oh, by the way, that's big bucks and whole lots of time. I said, nope, that won't work. Develop me some procedures for taking it apart in the field. We'll review those procedures. Our team will review them with you. If we're satisfied, we will proceed to do it that way. Well, we did. Took them out, all 3 tape recorders. No solder balls were found. Put it back together and just did functional testing, no environmental testing. And we flew. And it operated for 15 years, so I guess that was all right. Another interesting phone call was one morning, phone rang, and this gentleman says, I'm calling from Bar Harbor, Maine. My name is Max Anderson, and I'm getting ready to fly a balloon across the Atlantic. And I hear you guys got something that might be of use to me if I have problems. And I knew the right guy to call, Chuck Cody. And I called Chuck, and he'll tell you the rest of the story later. This is one that probably most people don't believe, but we actually did come in under budget on Nimbus 7. I don't know that any other mission can say that, and it wasn't massive amounts of money, but it was something around $1 million, which in those days was still a decent amount of money. I don't know about today, though. One last thing I'll close with. After I took over at TDRS, I went down to Johnson Space Center and was talking to the deputy director. And he was asking me, what had I done before I came on TDRS? And I said, well, the most recent experiences with Landsat and Nimbus, launched them last year. He said, oh, that's nice, but that's not really NASA. You know, I think the scientific discoveries and the technological advancements that we've seen from Nimbus and still seeing today with programs here at Goddard, that's real NASA. Thank you.